All right, we are recording.
Cool. So I wanted to let everyone know that we're going to be open sourcing the Steward repository. If everyone remembers, Jason, Kent, and I talked about Steward last week in the first of two presentations. So right after this, go to github.com/deis/steward. All the code should be there. We've got a bunch of issues. We've got some design docs, demo instructions, usage instructions, so on and so forth. So look forward to that.
Awesome. Thanks a bunch, Aaron. So, Kent, you had a couple topics you wanted to bring up today. You've got the floor.
Yeah, so basically, I know the topic has come up before of, are we going to have an API for the service catalog? And I believe there probably was some consensus that yes, we will. Although I don't think I was there for that conversation. I missed the first couple SIGs. But I think, or I want to propose that it's time that we start talking within the SIG about what that API might look like. And there's a few reasons for that. We feel internally at Deis, we've talked about this, and we feel that if Kubernetes included the primitives, if you will, that the SIG service, that the service catalog is built out of, that would have some benefits to those who are already cooking up implementations. So, Google demoed something last week. We demoed something last week, and we felt that if we started to define an API that may guide some of those further efforts and kind of put them on rails, as it were. So internally, we kind of, looked within Kubernetes for some inspiration, and we came up with a brief proposal on what we think this looks like, and would like to present that if it's okay. And this is by no means, fully polished. This is like a rough draft, and it's something we want to present to the community to at least begin fueling discussion. So is it possible, Paul, that we could go through that?
Yes, I welcome it. Feel free to share your screen.
Okay. All right, and you can all see my screen?
I can see it, yep.
All right, so I will share this deck with everybody after the meeting. So Service Catalog API, giving service brokers a Kubernetes native interface. So there are some motivations that I already kind of touched on here. We saw some good prototypes demoed last week. And moving forward, an API would guide those continuing efforts. It would improve the user experience by not relying on comparatively clunky third-party resource types. Anybody who's working with 3PRs right now will tell you that it's not the most pleasant user experience that you get out of it. And it would ensure a consistent experience across implementations without undermining competition or choice. And I'll touch on that last point further in a moment. So we looked within Kubernetes for inspiration. We didn't have to look far. And in persistent volumes, we found a problem space that seems like it's symmetric to the problem space of service catalogs. And we think that consistency is a virtue, and that the community benefits if this very similar problem is solved with a similar solution. So storage class, persistent volume, and persistent volume claim seem like they could be a good model for Service Catalog API. Also, we found a little bit of inspiration in Ingress. So Ingress controllers today are very different from the rest of the controllers in Kubernetes, in that an operator is free to pick an appropriate implementation of their choice. So we think there's room to do the same thing here, so that You know, the demos that we saw last week from ourselves and from Google could, you know, those prototypes could evolve to become implementations of the service controller that's described by this API. So this diagram shows the resources we're proposing be created. The first is a service class, which describes not a service, but a kind of service. The second is a service instance, which, as the name may imply, describes an instance of a service. A service instance is an instance of a service class. So one is the recipe and one is an actual functioning service. And, you know, I'll give the usual disclaimer that naming things is hard. And, you know, these names obviously are all subject to change. So just as with a storage class or a persistent volume, you have an operator creating these things. And then also, as with a persistent volume claim, we've created something here, or we're proposing something here rather, called a service instance claim that could be created by a consumer. It can reference a service instance if the consumer would like to bind to an existing service, but it can also reference a service class if the consumer is willing or wanting to have a dedicated service provisioned for them. And again, this is exactly symmetrical to what goes on with persistent volume claims, right? A persistent volume claim can reference a persistent volume if there's a particular volume you're interested in, but it can also call out a storage class and say, you know, I just need a volume, and here are the characteristics of the volume that I need. So the next few slides just kind of highlight the symmetry between...
Okay, can you describe the claim a little bit more? I apologize, I don't have the background with the analogy that you made.
Sure. So you know, using the analogy with persistent volumes, you make a persistent volume claim, or I should say a consumer makes a persistent volume claim to say either I need this particular volume or I need a volume that has these characteristics, right? So you may reference a storage class that says, you know, you might call it like a, I don't know, the names are arbitrary. It could be like a high performance storage class. And that storage class describes a disk of a certain size with a certain number of IOPS and is solid state, for instance. So the service instance claim here expresses your interest in a service, be it one that already exists or one that will be created for you.
So I have some questions about this, and I'm probably not helped by my familiarity with storage class because I keep trying to fit what you're saying about service class into the pretty detailed information I have about storage class. Mm-hmm. And as I've been opening my mouth to say these things, I've decided that they are better kept until the end. So carry on.
Okay.
Well, can I ask a question?
Oh, sure.
Yeah. What's is there a relationship between service instance claim and like a Cloud Foundry binding? Because it sounds kind of similar, but not quite, in the sense that a binding seems more like a real instantiation or linkage. But this sounds like it also could be more like a deferred request kind of a thing.
Yeah, the binding is really the output of the service instance claim is really the input to a process implemented by a controller. We're going to get to this, by the way. And the binding is really the output of that.
Yeah, so to give a little background on this, sorry. To give a little background on this, with this claim and sort of instance model, it was first used with pods and nodes, and then deliberately copied with persistent volume claims and persistent volumes. The binding is effectively represented in the claim, or in some cases both in the claim and in the instance that is bound to, which isn't the case for nodes, but is the case for persistent volumes because it's an exclusive one-to-one relationship. So there needs to be a representation of that exclusive relationship on both sides. And with a pod, you can just describe properties that are required for that a node has to satisfy for the pod, but you can also specify the node directly with the node name. So this is another instance of that pattern, and I pasted a link to a doc that wasn't completed, but that's sort of a write-up of this pattern. So I think it is good to reuse existing patterns from the system if it fits.
Yeah, I agree. And slightly going against my prior statement, I will also add a little bit of context to this, that the storage class is meant to be an input parameters to a provisioner that goes and creates a persistent volume that has the characteristics that are defined in the class. And so I will call out, like, I keep trying to make sense of service class in terms of that, and I'm having trouble. So I wonder if perhaps, I don't want to derail your presentation, but if we can discuss that later, the specifics about service class, that would be great.
Yeah, I have examples in later slides.
Can I also take this opportunity to ask, do you guys see a separate API resource for service plans that are part of the definition of a service in the Service Broker API?
So we don't have that defined anywhere here in this deck, but I can see it as a possibility.
Okay. All right, carry on.
I just wanted to add one thing, Aaron from Deis. We had discussed sort of two possible versions of that service plan resource. One would be kind of internal to the service controller, which we'll get to shortly. The other one would be sort of the official publicly exposed version. But as Kent said, we've kind of left it out of these slides here, and I think it'd be helpful to leave that open for suggestions, maybe after the SIG or at the end or something like that.
Sure.
Yeah, and again, I'll just remind everybody that we're not making any attempts here to like totally hit this out of the park here. We just want to get the discussion started on what this API should look like. So we may be way off here, but we just want to get the discussion going.
I will say my gut reaction is that I think discussing this is much closer to a productive resolution for what we think like V1 work product of this SIG is than using TPR. So carry on.
All right. Okay, so I just have a couple slides here that kind of highlight the symmetry with persistent volumes. It sounds like people don't really need to be convinced of that, so I'm just going to go through these really quick. The idea is that a storage class, like a service class, is defined by an operator. Storage class doesn't describe a volume, nor does a service class describe a service. A storage class describes a kind of volume. Service class describes a kind of service. And you also see there the standard disclaimer about naming things being hard. Okay, persistent volume is an instance of a storage class. Similarly, a service instance is an instance of a service class. And both of them can be statically provisioned by an operator and then bound to a consumer, or can be dynamically provisioned by a consumer. So I highlighted two use cases earlier, one where persistent volume claim mentions a particular volume that it has interest in mounting, versus just referencing a storage class and saying, I need a volume with these characteristics. The same is intended to be possible here, where you can either reference an existing service instance or reference a service class and say, hey, I just need a service that has these characteristics.
So can I ask a question? Like, I'm still trying to understand the metaphor here. So is a service instance returned by a service broker, or is it a service class?
Neither. So these are so service class is defined by an operator. Let's go back to diagram. So service classes and service instances are defined by operators. A service instance claim is created by a consumer, and it can reference a service class or a service instance. I guess what I didn't say that I should have said is that in the case that a service instance references, in the case that a claim references a service class, it dynamically creates the service instance. I think this will become more clear as we push through.
Okay, my mind is in readiness.
Okay, so the last slide, I got ahead of myself a few moments ago. I think I really touched on these points already, so we'll skip past that. And this brings us to the service catalog controller.
Sorry, could you actually present that?
Yeah, the things that are on this slide have already been stated several times, but it's just highlighting the similarity between a persistent volume claim and a service instance claim.
So one thing that I'm kind of wondering about is, for persistent volumes, I kind of understand the notion of you're asking for, if I understand what you're saying correctly, you don't necessarily ask for a particular volume. You ask for volumes with a particular set of characteristics. And you're just saying something similar here. And I get the sense that you're saying that a customer would come along and say, I want a relational database or something like that with a certain set of characteristics, but not necessarily come right out and say, I want MySQL. Is that correct?
Well, you're close. So we're imagining a consumer coming along and saying, I need a Postgres database, as opposed to saying, I need this specific Postgres database.
Now, when you say when you say you don't want them to say, I want this, do you mean you don't want this particular version of Postgres, meaning version 9 or something? Or you don't want this particular instance of version 9 of Postgres? Right,
instance of. Right, so there are two use cases that are accounted for here. One is where somebody wants to bind to a specific instance of a service. So this could be, to make that more concrete, which you'll see in the examples, that could be something like a shared zip code database or something like that.
Yeah, I think it'd be pretty productive to move into some of those examples, because a lot of the questions I think will be illuminated, at least, if not answered, in those examples.
Sure. So the service catalog controller is the component that actually deals with all of this. So it watches service instances and service instance claims. It delegates the discrete operations to the appropriate brokers. So those operations, obviously, I think we're all familiar with provision, bind, unbind, and deprovision. Upon bind, it manages the credential-bearing secrets. We also feel there might be room for the addition of an actual binding object here, which somebody asked about earlier as well. And again, I've included a point here that is something we've borrowed from the ingress controller, where we feel that there's room for more than one possible implementation here. So this is what it looks like, kind of in the middle here. If you can see my cursor, we have the service catalog controller, and it watches service instances, and service claims. In response to the creation of service instances or service instance claims, it will use brokers to provision actual services, and it will create credentials for those services. This is probably a good place to pause if anybody has a question about this.
Can you elaborate on the create flow for credentials?
Right. So credentials are, they are, well, in our implementation, we're working on Steward, obviously. In our implementation, the credentials are a secret. The credentials could just as easily be some new kind of type, like a binding type. It's within the realm of possibility that a binding type like a secret or a config map could be, mountable to the file system or usable with the downward API. But really the idea here is that after the service catalog controller has delegated a bind operation to a service broker and received back connection details and credentials, that it will at that point populate some object, be it a secret or something new. It populates that object with those credentials.
Okay, yeah, that's what I was looking for. It sounded to me like it might be creating a secret out of band relative to like the service broker API, but what I'm hearing is you take the response of the bind call to the service broker and turn that response, which is only characterized as secrets right now, into an API secret, right?
Correct.
Yeah, okay, cool.
And I just want to make sure one thing, because I think I agree with this, but I just want to clarify. The service instance in the top left-hand corner, you talked about that first, and then you kind of went over to the service catalog uses part. I'm assuming, though, the service instance gets created by talking to the service broker first.
Yeah,
so that
also what's missing for me. I have the same question.
Yeah, so the idea here is that when an operator defines a service instance, that the service catalog controller will see that event and will run a provision.
But doesn't the provision of the service instance by the service broker happen before the service instance gets created on the left-hand side?
Not in this model.
Okay, so I think that there are a couple terms that are overloaded in your proposal and in the service broker API. So entertain me, if you will, to start from the beginning. So in Cloud Foundry, what you do when you want to use the services a broker offers is you run a command that adds that service broker into the Cloud Foundry cloud controller, okay? The cloud controller then calls the service broker's catalog endpoint and pulls back a list of services that that service broker offers. What I'm hearing is that in the scope of your proposal, you're proposing that operators go and add those service instances manually. Is that right?
Yes, and I will. Yeah, would you like me to touch on why?
Sure. Yeah, I'm interested.
Okay, so we believe something that we have been, as we've been working on Steward, something that's come up frequently that we believe is probably a legitimate use case is that a cluster operator, an administrator, probably wishes to curate what kind of services are available within a cluster. So to give an example, there's an excellent broker that already exists for provisioning RDS databases. And it has probably about a dozen different service plan pairs that it offers. And those include things like different versions of Postgres in different sizes, MySQL in different sizes, and SQL Server in different sizes. Now, if I, as the cluster administrator, said, you know what, I don't want anybody provisioning SQL Server services for use with this cluster, then I need to have a way of addressing that. And my way of addressing that is that operators create service instances. So a service instance is a kind of service, or I'm sorry, a service class is a kind of service that is available, and a service instance is an instance of such a service.
Okay, so what I'm hearing is that, like, in lieu of permissions or another management mechanism to let the operator choose which services are exposed to which namespaces, service instances, that your proposal relies on manual input, right?
Yes and no. So we do have a security model with this as well, which we'll get into in the last couple of slides. But this has less to do with security and more to do with curation. We're looking at and this could be wrong. This could be a wrong way of looking at it, but we are looking at the catalog as the things in the catalog are curated by an administrator.
Yeah, and if I could just put this in sort of terms of how you would do this in Cloud Foundry. An operator adding a service class is roughly equivalent to running that command that spins up the broker. And then an operator creating a service instance is roughly equivalent to running the provision command.
But I think part that confused me, though, you keep talking about an operator doing the provisioning. In that particular scenario, is the operator the end user?
Kent, do you want to feel that one?
Maybe. I think that I don't want to sweep this under the rug. What I want to do, though, is if we can push through and get to the examples, I think it's going to, I think, as Aaron said before, I think it will illuminate some things.
Okay.
All right. So this next slide I'm not going to speak to. It's a big diagram. It's only for reference. So I'm going to share the deck afterwards. And you can all go through this at your leisure. It looks big, it looks complicated, but I think everything's in there. I don't want to waste time talking about it. We'll get into the examples here. So the first example here on the left is an example of a service class. So this would be something defined by an operator and given an arbitrary but semantically meaningful name. So this operator has called this one Postgres small. And through a service ID and a plan ID, this references basically an actual recipe that a broker that has been installed is capable of fulfilling. So the assumption here is that there is a broker working in conjunction with this controller, whatever implementation of the service catalog controller this operator is using. The assumption here is that when they've defined this sort of service class, that there's a broker that's able to fulfill this. So now that something exists called Postgres small, so again, it's an arbitrary but semantically meaningful name, we see over here on the right, we have an example of a service instance. And the name it has been given is zip code DB. So again, arbitrary name, but semantically meaningful, at least in comparison to, these very opaque identifiers like service ID and plan ID. We're trying to give things meaningful names. And in the spec, you see that it references a service class and it references Postgres small. So the expectation here is that by defining a service instance with a service class of Postgres small, what will happen is that a service will be provisioned, and it will be provisioned by a broker that's capable of fulfilling this. Does this sort of make sense so far? I'll pause for a couple questions.
So it could be any broker, because I asked because it sounds like it might be indeterminate which broker is going to satisfy this, which is something that is, it's a notion that's not present in the existing body of work that's like coming out of Cloud Foundry on the on service brokers. So in the Cloud Foundry model, a service, what is analogous to service class, has a relationship one to many broker to services relationship. So there's one broker that uniquely offers a service class.
Right. So the assumption here is that if you are defining this service class that I have right here, the Postgres small, you, the operator who defined this, have the knowledge that you installed a broker that knows how to respond to this service ID and this plan ID.
Yeah, I assume there was a relationship by the service class name on the service instance that pointed back to the service class, and I told you exactly which broker was going to deal with it.
I mean, it kind of looks like it is introducing an additional level of abstraction on top of what the Cloud Foundry model is. I mean, it's something that we've talked about internally, whether one should think about this at some point, where you could say, hey, I want a, something that speaks MySQL protocol, and you can sort of ask for it generically, and it could be satisfied by any number of different brokers. But it's not something that we've really spent any time on. But the service class, the sort of the generality of it seems to speak more to that. And the service ID, plan ID, obviously is right in the line with Cloud Foundry. I can't imagine those being generically supported by different services.
Yeah, and one of the validations that you perform, or that the Cloud Foundry Cloud Controller performs, is that the service ID and plan ID are uniquely identified. They're unique identifiers, and there has to be referential integrity, as I understand it, between the unique ID for the broker and the service ID and plan ID. So if you have a broker that returns back a service ID that already exists from another broker, that's a validation error, and that will prevent you from registering that broker.
Yeah, I hope that I haven't implied something here that I think I did. I don't mean to imply that there might be more than one broker out there that's capable of fulfilling this, this service ID and this plan ID. I'm not looking at this as some kind of interface, right? It's known to the operator that they have a broker available to them that can fulfill this service ID and this plan ID. And they've created a service class that just attaches a friendly name, a friendly semantically meaningful name to that service ID plan ID pair. That's all it is. There isn't, there isn't any assumption here that there might be more than one sort of broker out there capable of fulfilling this.
Yeah, I'm looking at this service class as sort of like the output of a Cloud Foundry register service broker. Because at the end of the register service broker, you get basically a list of services that are available to you in the marketplace. And I think each one of those things in the marketplace represents your service class here. Do I have that right?
Yes, that's correct. That's very similar. The only thing that's different here is that because this is defined by an operator, the contents of the catalog are curated. We're not just querying every broker and saying, hey, what are all of your offerings, and then blindly dumping them into the catalog.
Okay, yeah, minor difference, but yeah, okay, basically the same thing though. Okay.
Yes, yeah. So what you said is correct.
Okay.
So if we move on to the next slide, there's some more interesting things on here. So we have two different service instance claims here that illustrate two different use cases. So on the left, we've made a claim. We've called it my zip code DB claim. And the spec calls out a service instance zip code DB, which was defined on the previous slide. And a target secret, so we're just naming the secret that we would like our credentials written into. And the little note at the bottom points out that this is an example of binding to an existing service, because we're calling out a service instance that already exists. Compare that to what you see on the right, which is a service claim that the name of that claim is my app DB claim. So this is an example of a consumer who just needs a Postgres database for their own use. They'll populate it themselves. They'll manage the schema themselves through migrations or whatever. They don't intend to share this with anybody. It's dedicated to them. So they have, in the spec, called out a particular service class, Postgres large. So that's a semantically meaningful name for a service class, which identifies a service ID and a plan ID that some broker is capable of fulfilling. And once again, specified the target secret that they want the credentials written into. So what logically happens in response to the creation of the one on the left is just a bind. What logically happens in response to the one on the right is a provision and a bind.
So what's the value of having a separate way of doing that? I mean, why don't you just create the service instance and then bind to it on the right-hand side?
I suppose that's a possibility. Again, I did model this after persistent volume claims. And so I drew the inspiration from there, and this is pretty much the way that works. You can call out a storage class, and if a suitable volume doesn't already exist, it will be dynamically provisioned for you. I'm just following the same pattern here.
And also, I wanted to mention one proposed benefit that we have here is that when you do something like on the right, it's possible that you could actually be guaranteeing mutually exclusive access to that resource. And we would do that, of course, by having the service controller not create a publicly accessible version of that service instance. And in doing so, it would prevent anyone else from binding to that service instance, which of course would make that guarantee that the person who created originally the claim would be the only one who could use it.
Yeah, I'd like to see more exploration of these concepts because there is a notion of visibility in Cloud Foundry that I think is somewhat tied up in like the last few stanzas of the conversation. Can I also ask, like, I see that you get a secret, and I'm guessing target secret is the secret that you want to create in the namespace of the service instance, right?
Yes, so that's a secret created in the same namespace as the claim.
Okay.
And it would be populated by the controller with the credentials that it received upon binding.
Yep. And we'll make PC. How about a Kubernetes service?
I'm sorry, what was that you cut out at the very end?
So what about a Kubernetes service in the namespace too? There are use cases where a pod does not have generalized access to the internet, and it needs services to poke firewall holes in so it can reach things. So do I get a Kubernetes service in my namespace too?
I think that seems like a reasonable thing. If that became if that were documented as a role or responsibility of the catalog controller, I think that makes a lot of sense.
Okay. Yeah, that's something that I see being useful because then you also get injected with service links, environment variables for that service, and there's demand in the community for a mechanism to allow explicit linking so that we can stop generating massive amounts of environment variables that we could piggyback this notion off of.
Yeah, just to give some people a little bit who aren't familiar with the persistent volume claim, persistent volume model, a little bit more context. So the reason why we have both persistent volume claims and persistent volumes, and also both pods and nodes, there are a few motivations. In the pods and nodes case, obviously nodes are shared. Multiple pods can be bound to node and share those resources, and that also matches some use case for service instances. They can be shared amongst potentially multiple claims. Another is the scope. The nodes and persistent volumes are cluster scoped, whereas pods and persistent volume claims are namespace scoped. The idea is that the nodes and persistent volumes are provided by the cluster, and then they're consumed by specific users in a specific namespace. So I think it's a little bit unclear whether that is also the case with service instances, so that's something worth thinking about. And then also nodes and persistent volumes are expected to be, at least in some use cases, pre-provisioned. Like nodes are pretty much always pre-provisioned today, modulo some cluster autoscaling, though we would like to dynamically provision them more aggressively in the future. And persistent volumes, an administrator might need to manually provision some ahead of time depending on what their storage solution is. But we do have, for public clouds and other environments that support it, dynamic provisioning. And as discussed, I think dynamic provisioning, especially for what are effectively single tenant services, makes sense in this case as well. So definitely some of the analogies to the model hold, and it's worth thinking about what the differences are as we move forward with this.
So getting through the last little bit here,
before you move on, can I ask just one question? I apologize if this got asked because I got dropped. But when you talk about binding there, you're not actually binding to an application or something running inside of Kubernetes yet, right? You're just creating the secret, and it's now up to the person who wants it visible inside of their application that's running inside Kubernetes to grab that secret and make it available through whatever means they want, right?
Yes, that's correct.
Okay, just want to make sure. Thank you.
All right, so somebody was just talking about things existing either within a namespace or within cluster scope. And I can actually speak to that a little bit here because we did think through some of that. So I used the word global here, but I probably should have said cluster scope. So service classes, like storage classes, we were imagining to be in a cluster scope. But an admin may want some of those classes provisionable within some namespaces, but not others. Imagine that you have two different teams who are sharing space on the cluster, and one of those teams is full of top-notch developers you trust, and they'll clean up after themselves, and you don't mind if they go provisioning certain expensive things because they'll clean up when they're done. But you have some other team, you don't want them doing that. There needs to be a mechanism to enforce that, despite the fact that this is in a cluster scope where the usual protections afforded to you by namespaces don't necessarily help you. So we would propose that we could create something called a provisioning policy that would be a way to constrain the dynamic provisioning of services to consumers in one, some, or all namespaces. So basically, as an operator curates the so-called service catalog, they also have the opportunity not only to say what services are available, but also to say, what namespaces those become available to.
So I'll add some context, which I'm not sure is well socialized yet in the wider community, because it is ongoing in the storage SIG now, and we have some folks at Red Hat working on it. So with storage classes, it looks like we're going to try to solve the problems that provisioning policy solves with quota, so that you can quota the number of claims of a particular storage class within a namespace. So there's a couple facets of this. One, objects that are quoted right now. If you don't have a quota in your namespace for that object, you have unlimited access to it, which is the opposite of how we want it to work for storage classes. So there's a facet of this work where we are making, when I say we, I mean the community across Red Hat, Google, other companies. The community is making it possible to express that a particular resource is precious somehow, so that if you don't have a quota defined for it, it means that you have zero quota. And then the other facet of it is, like, how do you express a quota on these arbitrarily defined storage classes and count them? And the method that looks like is going to be used for that is that we're going to define the way that you reference a storage class in quota will be something like storage.k8s.io/name of class. So I think it should be hopefully understandable how those two primitives can give you this kind of policy, but I just wanted to throw that out there because it's been a topic of some discussions that I've been involved with recently, and I'm not sure how well socialized it is yet.
Yeah, I'll say again that I think it's a benefit to everybody when similar problems have similar solutions. So if that pattern emerges as something that's a good solution for this kind of scenario, I think absolutely the way that we've envisioned the provisioning policies could probably move aside and be replaced by this like quota strategy.
Paul, do you know how we quota node port? Do we know?
I actually believe, Brian, that node port is limit ranged. I don't think it's quoted. I could be wrong.
Okay, I'll check.
All right, and then really the last thing is binding policy, which is similar to the provisioning policy. This is more applicable to the multi-tenant scenario. So if you're an operator who has statically provisioned a service instance, expecting that others in multiple namespaces may be binding to it, you may want to restrict what namespaces are able to do so. So it's similar to the provisioning policy, but it's more about who can bind rather than about who can provision. And that takes us to the end. I think actually there have already been a lot of questions, but I would just return this to open it up to the floor and yeah, that concludes the presentation.
Okay, really awesome presentation. Thanks a lot to everybody from Deis that was involved in that. I see that we are nearing the end of our allotted time. I think we all probably have different tolerances for going over. So I wonder if we can agree on a couple major points and perhaps discuss in Slack or in proposals to the incubator repo some of the finer points. So what I wonder from folks is, does anybody disagree with the utility that having a Kubernetes-like API on top of these concepts provides? Just to clarify, I'm in the camp of I think this is a very useful concept to have a first-class API around this, and I'm looking to see if we have any dissent.
I just want to clarify, Paul, that while we're at the prototyping stage, I think a third-party resource or a separate API is just fine. I mean, it makes it a little bit harder to do some of the control tooling, but other than that, the controller patterns and whatnot can be totally fleshed out. I think if we're going to use something like the federated APIs or even third-party resource, either one, I think a little more work is going to have to be put into those.
Yeah.
Other those mechanisms, and definitely in Q4 we don't have anybody who can do that. And the 1.5 is shipping today, basically. In terms of the feature repo issue.
Yeah, Brian, just to clarify my own desires and intentions, like I would like to see this be an external API that was Kubernetes-like that you use via federation. I don't necessarily think of this as something that we want to add to the core. So that's where my own personal thinking lies. Okay, it sounds like we don't have anybody that's saying, no, we don't really need something like this. Any other questions that folks want to get to in the next few minutes?
Yeah, I just have a couple of questions. One is, are you working towards prototyping this pattern? And I also just have a point, which is, people have talked about wanting to know specifically what services are bound to what other services. And one thing that came up when we discussed the claim model before, I think, with the Red Hat proposal, is that it allows you to know what the namespace is consuming a service, but not sort of more specifically, unless we also are able to pick up information from pods or some other ID to give some notion of who the consumer actually is, more specifically than just the namespace.
So to the first question of whether anybody is prototyping this, that's a yes and a no. So internally within Deis, as we cooked up this presentation, we were really basing this on a couple things. One being, as I said, we drew inspiration from how these things are already solved within Kubernetes and other problem spaces like persistent volumes. But then we also looked at it from an angle where we were trying to imagine the types of resources that we wished existed as we had gone about implementing Steward. So we believe that if these things were to come into existence, if this did become an API, we believe that we could take our own implementation and with a fairly minimum amount of work, retool it to work with these first-class resources. I'm sorry, what was the second question?
It was sort of more of a point than a question, but some desire has been expressed in the past to more specifically identify the service consumer than the whole namespace. The mental model is service-to-service connections.
So Gabriel actually had proposed that we may want to augment this proposal and add in another type of resource called like a service binding or something like that. So that would be another first-class resource, something that you could actually query to kind of understand that map of what's bound to what.
Brian, just so you know, in terms of implementation, there are some of these concepts that are already being prototyped in the joint CNCF Cloud Foundry working group. So it's some different names, but very similar concepts.
So one thing that one reaction that I had to this is that as an operator of a like multi-tenant online PaaS, I would prefer not to have to manually enter the details of every service that I wanted to expose from a service broker. And so my own thoughts about this have been like, I sort of expected to see a service broker API object. And not to derail the discussion, I'll try to give a concise explanation of this. Say that you have the service controller is watching that API resource. You add that resource into the catalog, or you add that resource, an instance of that resource for the service broker that you want to add, and the controller goes and calls the catalog endpoint on that service broker and populates, I guess it would be service classes in the catalog from that. I expected to see something a little bit more like that. And if you want to curate and make it so that you do not expose everything that a broker offers, you add some level of indirection like a visibility flag or a specific, or maybe a policy object, and have a special resource that is namespaced, that clients in a namespace can call to see which catalog entries are visible to them. And I recognize that is a little bit of minutia, but the broad stroke is that, like, as an operator, I want to easily be able to see a resource representation of which brokers I have, and see what their status is.
Yeah, I agree with that, and I think that if you know, as a group, if we can agree on some better option for how to curate the catalog without so much manual effort, I think that would be great.
Okay, so Doug has noted that we're at time now. We went over last time, but meetings running over is kind of a pet peeve of mine, so I'd like to keep this within the bounds that we scheduled. I think that we can continue this discussion on Slack. I think this was an awesome presentation. It's a huge step in the right direction. And so what I suggest that we do as next steps is let's continue the discussion in Slack. And as we arrive on consensus on parts of this, I think that we should start making polls to the incubator repo to put into a markdown document what we think the Golang type definitions for these things look like.
Yeah, I think that all sounds pretty good.
Okay, awesome. Well, thank you again for the presentation. I'm going to put this on YouTube after this meeting and send out the link to folks that may have missed the meeting. And we'll see everybody next week.
Awesome. Thanks, Paul.
All right. Thanks, everybody. See ya.
Thanks, guys.